In this video, I'm going to go through the code for the example we have explored in the previous video for the depth-first search algorithm. And if you want to revisit that video, the link for it is in the description. So as we have explained, the DFS or depth-first search algorithm uses a stack data structure and a set data structure that will store the visited nodes, so we would avoid redundant or cyclical traversal. It also uses a next function, which we'll visit in a moment. So first thing, we start by identifying our start and goal coordinates, and in our example, it's 0, 0 and 3, 2, our goal. And then we're going to add that initial coordinate to our stack, and that's what the stack.append start. Of course, I'm using a Python list here, so I'm not using the traditional push and pop, so append is technically the push. Now we're going to iterate through the stack, so we're going to keep repeating this algorithm as long as we have something in our stack. And if we run out, it means we couldn't find our goal. So first thing, we pop the stack. If you remember the algorithm video in the previous video, so we pop the stack and we check our item. Is it our goal? If it's yes, then call the function and return. Here I'm printing done. Otherwise, look for the next steps, calling the next function. And we're going to give it the coordinates of our current location and the maze. Then we're going to iterate through the next steps, and we're going to check if that next step, the coordinate of the next step, is already visited. If it is, we're just going to skip it. Otherwise, we're going to add it to our visited set, and we're going to add it to our stack, and we're going to repeat again by popping what we have added to the stack. We check if it was our goal, and then we look for the next step, and we iterate through every one of the steps in the next step, and we check if they were visited. If not, we update the visited set and we push it to the stack. That's basically how depth-first search work, and as you can see, it's very simple. Now the next function is basically just a quick check if the coordinates that were given to us, if it's an edge, so that's what these, so coordinates are tuple, that's why we're checking 0 for the rows and 1 for the column, and here we're checking if it was on the edge of the maze, and if the next block or the next node does not equal to 1, and 1 in this case is blocked because in the maze I'm using here in this example, 0 is an open square and 1 is a blocked square. So this is our stack. It's empty list, visited, empty set, that's our maze. Zeros are open, 1 are blocked, and we call the DFS algorithm, give it the maze, the stack, and the visited, and then it should take us, walk us through our maze squares or nodes all the way from the start to the goal. So let's run this script and or this function, the DFS function, and let's see how it worked. Start from the beginning. So that's the first thing we did. We added the 0, 0, the start coordinates to the stack, and we popped it. Ask if it was our goal. No. We check our next steps. So evaluating 1, 0. Since we have not visited 10 yet. We add it to our visited nodes, and then we push it to the stack. And we continue the same way. We pop the next item in the stack, which is the only coordinate, 10. Is 10 my goal? No. And then we call the next function. So the next steps are 0, 0, 2, 0, and 1, 1. Then we're going to iterate through the next steps. 0, 0, have we visited 0, 0? No, we add it to our set. We also add it to our stack. And now we're evaluating the next coordinate, 2, 0. Have we, yes, so have we visited 2, 0? No, so we add it to our visited nodes, and then we push it to our stack, 0, 0. Now the stack has 0, 0, and 2, 0. Now we're evaluating the last coordinates in our next steps, which is 1, 1. Have we visited that node? No, we have not, so we add it to our visited nodes, and then we add it to our stack. So now the stack will have 0, 0, 2, 0, and 1, 1. Now we'll walk through each one in coordinates in the stack. So we pop 1, 1 first. Is 1, 1 our goal? No. What's the next step from 1, 1? It's 1, 0. We're evaluating 1, 0 against our visited nodes. 1, 0 has already been visited, so we're going to skip it. So and now we're going to go to the next item in the stack, which is coordinate 2, 0. Is 2, 0 my goal? No. Where can we go next from 2, 0? Again, we're going to go back to 1, 0 and 3, 0. Can't go to this one because it's blocked. So we're going to iterate through the next steps. 1, 0. Have we visited 1, 0? Yes. So we'll skip it. And now to the next item in the next steps. 3, 0. Have we visited 3, 0? No. So we add it to our visited nodes, and then we push it onto the stack. So now the stack will have 0, 0, and 3, 0. And we continue the same way. We pop 3, 0. We run it through the same evaluation, and we'll end up with 3, 1. We pop 3, 1, and we run it through the same evaluation. As you can see, our visited nodes has been growing bigger and bigger. That's for every node that we have visited. Evaluating the node, 3, 0 already exists. Popping 3, 0. Popping 3, 2, that's the next item here. 3, 0 is popped. 3, 2. Is 3 to our goal? Yes, done. So if we go back to the last printed out visited nodes, this will show us the path that the DFS has taken to reach our destination goal. So we visited 0, 0, we visited 3, 1, we visited 1, 1, we visited 2, 0, we visited 3, 0, 1, 0, and 3, 2, and the final point 3, 2, which exited or returned the function. That's why it's not shown in the visited, or it's not, the visited nodes has not been printed out. So this is the DFS algorithm and the code and the walkthrough. If you want to see this code, it's saved in GitHub, and the link to that repo is in the description.